All right. So now I will quickly take you through the solution for the autoresponder use case that we discussed. I'm not running it because it will take time, but this is again the data set that we have if you see. So we have inputs, which is the mail or the particular question that was asked, and we have the response. So we have the few short examples that are given. And this is what I was actually discussing. If you do a value counts, you will realize that there are only five unique complaint response categories that we have. And another very, very important thing I wanted to highlight is the distribution of the data. You can clearly see that there is a huge amount of imbalance in the data. So there are 18 different examples of the first type of response, but there is only one example of the fifth kind of response. So we have a huge imbalance in the data that we can see right now overall. So the data is very, very, distributed in a very, very imbalanced manner. The same for the gold examples. And this is the other aspect that we were discussing. So you can see there are five unique examples in five unique categories in the few short examples part, whereas there are six unique categories in the gold examples part. And even that also goes to show that the distribution of my data is not ideal. So ideally, we should have the same type of examples and the same number of examples in both few short and gold. Okay, so the distribution has to be the same. So obviously, the gold example should have more number of examples because, as I told you, 20% for few short, 80% for gold. That's going to be the ratio usually, but the distribution has to be similar. Here, the distribution itself is very, very different. So now we try out the prompt engineering part. You can see that we are saying so uh, respond with this thing. This is the detailed system message, and we are trying out with different variations of the system message. This is a few short part. This part is straightforward, very similar to what we talked about. And see, I'm solving it like a classification problem. The moment I solve it like a classification problem, I'm getting only a 6.25% accuracy. This is not surprising because I told you that the data is very, very imbalanced and it's not right. We need to do it in a very detailed way. So the moment I solve it like a classification problem, you're getting a very, very poor result. And why is it classification again? So although it sounds like a generation problem, although it sounds like a generation problem that we want to generate or predict a new response, but it's not an open-ended response. If you look at company policy, the response only has to be from these five distinct categories. The response only has to be from these six distinct categories. So it's not exactly an open-ended generation. If I ask 20 of you in the class to, uh, you know, give a company response to a particular input, you will not give random responses. You will want to give a response which is in line with the company policy. And that is why, although this looks like a generation problem, it is actually a classification problem. So the way we should ideally do it is we should go and uh, label encode these responses. This is response 0, response 1, response 2, response 3, response 4, and response 5. The sixth response will be actually response 5. Again, the distribution is not right, I told you. And then we will use a prompt to a system message will clearly specify that output these 5 to 6 different types of responses and then go back and do the prediction. So that's the way how it will work out. And this is actually the other problem that you're seeing. Okay, if you take a look at it in the system message very clearly, I only give 5 categories. Can you see? This is again the distribution of my data is to blame. The data curation is to blame. So I've only given the 5 categories. And as I told you, this is not a good practice to give the whole text. Give the labels 0, 1, 2, 3, 4. Okay. So only 5 categories are given. But remember, in the gold example, the validation, the test set, we actually have 6 categories. That's the problem. So although I'm giving 5 categories here, but in the validation set, I've actually got 6 categories. And that is what is really causing the problem. And you can actually check which one is the one that is not present. Okay, anybody can find out which one is the one not present. So company chooses not to, this is there. Believes it acted, this is also there. The third one is also there. The fourth one is not there. This one is not there. The company believes complaint caused principally by actions of third party outside the control or direction of the company. This one is not there. So this is there in the validation set, the gold examples, but this is not there in the few short examples. So there's no way to uh, explicitly. So in a way, my LLM will not even generate that kind of an output, and that's a problem. You can see how serious this flaw is. This is actually an expected response, but because I don't have it in the few shot, I'm not putting this in the system message by mistake. So we have to tune the system message, and because of these kinds of reasons, my overall classification accuracy is very, very bad. But as I told you, we can modify the few shot prompt. Here I'm modifying it. I'm making it better. we have introduced some chain of thought prompting, COT prompting. And once I do that, I'm getting a 31.25% accuracy, which is much higher. And if you come all the way down, this time I'm trying using BERT score. This is what most of you did. You tried with BERT score, and with BERT score, we are getting a very high answer. And what is the reason why we are getting a very high accuracy, a very high BERT score in this particular problem? Because semantically, the responses mean the same. The meaning of the responses are the same, although there are 5 to 6 different categories. But if you look at them semantically, they're all talking something to do with company responses, either company responding or choosing not to respond, or withholding the response, whatever. But they broadly all mean the same thing. Okay, so in terms of classification, if you just look at the accuracy, it will be very bad because we want the exact response to come. But if you look at a semantic comparison, are they similar? Yes, they are very similar. That's why the BERT score is high. But as I said, the BERT score is not the best way to evaluate these kinds of things because this is company policy. Even if 1 or 2 wordings are changing, then maybe some customer, if you're giving a wrong response, even if 1 or 2 words in the customer response is wrong, in lawsuits and in a legal, in the court of law, it can be very expensive for the company. Okay, so these are very real things that you need to consider when you're building problems, when you're solving problems. There is one more very interesting use case I wanted to generally talk about. This is already uploaded in your folder. You can take a look at the generation folder. I've already uploaded that. This is actually how we use generative AI for content summarization. Okay, how do we use generative AI for content summarization? So to explain this in a little bit more detail, let me go and take up an example. Okay. So what I have done is I've actually opened up a YouTube video just to show you the real use case, what we are trying to achieve here. So you can see, very interesting. So all these YouTube videos, what they do is they come with subtitles, right? All of you know that. I'll turn on the subtitles and captions basically. And this is a video where they explain language models. So very interesting. So the language model is explained here in this particular video. All of you can see. Okay, just 1 minute, please. Okay. So the objective of this exercise would be to look at the video. So to go to our website, download the YouTube video, right? So to go to the website, we want to download the YouTube video, and from that YouTube video, extract the audio component out of it. That can be done. There are Python libraries which you can use to do that. I'll show you very shortly what those libraries are. So we can go to any YouTube video. We can download the YouTube video. We can extract the audio component out of it. Only the audio component we can download. And there are a lot of tools you can use for that. A lot of these video editing tools, they come with ready-made softwares which you can use to detach the audio. Only the audio part can be detached. And in Python, you can very easily do it. And from that audio, we will use speech to text, right? Although here, by default, YouTube is giving you the captions. But behind the scenes, remember, behind the scenes, it is using a deep learning model to create the captions. Okay, so some kind of deep learning model has been used to generate the captions. So that is what is happening behind the scenes. Real time, the caption generation is happening. So based on the video, the model is real time generating the captions. It is using a speech to text model. And if you remember from yesterday's conversation, we were discussing that beautiful use case of Lura AI. Remember, Lura AI is a model that is used to it helps you basically learn English, right? You say something in English, and Lura AI gives you feedback in English. So when you say something, you're doing speech to text. Internally, it is getting converted to text. So I will, let's say, it asks you to pronounce, let's say, my name is Shayan. So I say, my name is Shayan. So what it does, it actually takes whatever speech I'm using, whatever audio pattern I'm using, it will convert that speech to text using a Whisper model. Okay, so Whisper is a model that is given by OpenAI. OpenAI has a model called Whisper, which is used for doing this exact same thing, speech to text. The first level will be speech to text. Whatever I'm saying will be converted to text. That text will be processed by your language model behind the scenes, and then the summary will be returned back. That is exactly the use case of this thing. Okay, so you take a YouTube video, take the audio part out of it, speech to text, take the text part of the audio. So do the entire transcription of the YouTube video, take the complete text, whatever is talked about in this hour-long video. Okay, and then what do? We take that whole text and generate the summary. So it's a video summarization use case. In short, in 5 words is video, 2 words is video summarization. That's what we are trying to do. Okay, and this could be very helpful, right? Because the creators can now use this kind of technology, and when they want to create some video, like in this case, Andre Katpati, he's a very popular editor. Okay, it's a very good author, actually. He has some very good videos, right? So what they can now do is they can now look at the summary, they can look at the captions, and they can themselves internally use a transcription model. Then they can use a LLM to summarize it, and they can get this thing. YouTube does it automatically for you. If you're a YouTube creator, YouTube gives you tools which can automatically do all this for you. But now we understand how this thing happens behind the scenes, right? Even if you look at Truecaller has some of you might be using Truecaller. So Truecaller has come up with a lot of incredible features. Okay, and one of that is obviously call summarization and call transcription. This is not a new thing. A lot of companies are coming up with these kinds of solutions today. So Truecaller has this thing called call recording and call transcription. So what you can do is you can record the call. Okay, you can record the call, and you can also go back and generate an entire summary of the call. Okay, so all those kinds of things are there. If you have a Galaxy device, Galaxy AI also comes with these kinds of features, Samsung Galaxy. So next time somebody calls you, you can record the call. The whole transcript of the call will be recorded. It's a huge amount of text will be there. And then on the basis of that, the summary can be generated. And you will get just like a meeting summary, you will get a call summary, which talks about, what kind of things were discussed and all that. And you'll be surprised to know that it is very much language, it takes into account the language. So and that is the next big revolution that is happening today, where all these language models are working with respect to different languages. Like you might know the Grok 3 model by XAI. XAI is the Elon Musk's company. The Grok 3 model actually does very well in Hindi. Even if you say something in Hindi or write something in Hindi, the Grok 3 model actually does pretty well in Hindi. Even ChatGPT for that matter, and it depends a lot on the models. But if you look at DeepSeek may not do that well. Okay, so DeepSeek may not do that well. But if you see many of the other models, like if I go to ChatGPT and say, kaise ho, if I go and ask this kind of a question to ChatGPT, if you see, look at this, it will actually answer it. And what is the reason? Why is it working? Because it has been trained based on these kinds of tokens. And not only that, it is actually, what do you say? It's using Hindi English as they call it, no? Like normally when we use the English keyboards, we also write it this way, no? We don't use the Hindi tokens. But this is interesting. This is actually very hard, actually very hard for the model to understand. It's all about associations. The language models are all working based on associations, how certain types of words are getting used. So if you look at the word may, if you look at the word thick, main means something very different in English, right? Main is what? Main means something important, main. So main, the word means something very different in English. But the word main, the token main, in the context of what you are seeing right now means something very different. So all these language models are working based on context, association. What is this in the context of all this, right? And you can try it out. You can now go to maybe, let's see if I can, if I can do this. Mm. See, I'm just randomly pinging some tokens. You can just actually kind of see whether it works or not, and you will see that it actually does work. So ChatGPT as we speak today is trained based on Hindi tokens. So you can actually interact with ChatGPT even in Hindi. It doesn't have to be only the Hindi English kind of tokens. So ChatGPT has also been trained based on this. This is again a feature of the language models. Internally, the models that are there, what they are trained on. But this may not be the case for DeepSeek. ChatGPT may not be that good in Chinese, But DeepSeek will be very good in Chinese because it's a Chinese model. It has been trained on more Chinese tokens, and so you need to be also aware of these kinds of things.